Okay, good morning and welcome to Math 9. Today we're going to be reviewing or beginning a review of rational numbers. Just remember that last day we gave you a pre-test that should have been completed and sent to me. The home support student should have sent it to me by email. And if you're in the classroom, you should just put it into my basket. All right, so here you'll see what we're going to be doing. We're going to just look at placing negative sign for equivalent fractions. I'll go over what an equivalent fraction is. We're going to change a fraction to a decimal. We had a little bit of that as a review, but I'll show you how to do that again. And then placing decimals and fractions on the number line. So we're going to be using pencils and papers to do this. And at the end of the lesson, after you practice your assignment, you should know how to write equivalent fractions with negative signs. You should know how to make a decimal from a fraction and how to place a decimal on the fraction line. So three easy little things that we're going to try and learn today. So just to quickly review, a rational number, if you may or may not remember from your previous grade, is any number that can be written as a positive or a negative or as a fraction. You'll see here in the little diagram that we have, the first set of numbers are natural numbers. 1, 2, 3, 4. All the counting numbers are natural numbers. And we card them as whole numbers. Now, if you take all the whole numbers, the 1, 2, 3, and 4, and you write the negative to them. So if I have a plus 2, that's a whole number. And if I write the negative, a minus 2, then both of those numbers are called integers. So plus and minus of whole numbers are integers. Okay? And then if we have numbers that include fractions, like 2/3, and plus 2, and minus 2, then that group is called rational numbers. And all of those numbers are called real because they also include numbers that are irrational. And we won't spend much time on that, but an irrational number is something that doesn't stop, like pi. On a calculator, if you were to put that in, you would get a number like 3.14 and a whole bunch of numbers that would go on forever. They never stop. But rational numbers stop. Like a number like 2, you can write it like this, it stops. And if I have a number that repeats, if I write 1/3 and I write it as a decimal, it goes on forever. So when we have repeating numbers or numbers that stop, those are rational numbers. Yeah, you would write 0.3 or 0.33 with the bar on top, meaning that it repeats. Right. So just think of it. If you can take any number and write it as a fraction, any number. So 1/3 is a fraction, right? 2, that's a whole number, but I can write it 2 as 2/1, because 2 divided by 1 is still 2. But this number here is a fraction, 2/1, right? So I can write that, that's a rational number. 3, that's a whole number, but I can write it as 3/1. So that makes it a rational number. But if I took this number, I can't write it as a fraction because it never stops. So rational numbers stop or they repeat. Now, what's an equivalent fraction? Well, remember, if we have a number like a fraction like 5/10, we can simplify that. We can make it smaller. If we divide that by 5 on both the top and the bottom, 5 divided by 5 is 1, and 10 divided by 5 is 2. So that means 5/10 and 1/2 are equivalent. They're the same. If I take 5 and say I multiply it by 2, and I have 10, and I multiply it by 2, 5/10 is a fraction, and I multiply both the top and the bottom by the same number, that's 10. 5 times 2 is 10. and 10 times 2 is 20. Well, then 5 tenths and 10 over 20 are equivalent. Equivalent means they're the same. They have the same value. Okay? Fractions, you can try and break them down to the simplest form, like here. We can break it down into, but we can't go any further than that. It stops there. Okay. So, equivalent fractions are different fractions that name the same number. Different fractions that name the same number, like 5 over 10 and 1/2. So here are some examples right here. 2/3 and 4/6. So writing it like this, 2 over 3 and 4 over 6. They're equivalent because if I multiply this by 2 and this by 2, I get 4 here and I get 6 there. So that means they're equivalent. Or if I took 4 over 6 and divided by 2 and divided by 2, I can simplify it to 2 over 3. So that makes that equivalent. Okay? So here are some in the pictures that are equivalent. 1/2 of a square. And if I take my square and divide it into 4 parts, it's 2 over 4, but it's still 1/2. And if I have say a pizza and divide it in 8 pieces, or 16 pieces, and I just take 8 of them, 8 over 16, I still have 1/2. So all of these equations are equivalent. They're all the same. And if I were to divide 1 over 2 and make it a decimal, 1 over 2, I get 0.5. If I take 2 over 4, 2 divided by 4, I get 0.5, 0.5. And if I have 8 divided by 16, 8 divided by 16, I still get 0.5. So because I have the same decimal fraction here, all of these fractions are equivalent. Okay? Very good. Now, what if we have a negative sign? Well, if we have a negative fraction, -3/4, remember that these numbers for integers can either be positive, and this is a negative. This is +3/4, this is -3/4. But when I write -3/4, that means it can either be -3 over +4, or it could be +3 over -4. They're all the same. These are equivalent negative fractions. Okay, so you can either put the negative on the outside for the whole term, where it means that the top is negative and the bottom is positive, or the top is positive and the bottom is negative. All make the fraction negative. Okay. Now, if there are 2 negative signs, they're going to cancel out. So, let's say I have a -3 over a -4. Well, -3 divided by -4, these negative signs will cancel out. So now they become positive. So anytime you have a negative divided by a negative, negative divided by a negative, it becomes positive. Okay? So that would be written as positive 3 over 4. So the bottom line is that -3 or -4 is equal to 3 over 4, positive. Changing a fraction to a decimal. Now, when you get your notes, I put it on your Dropbox, and also the home support will have it in this copy of the video. I want you, where you see this copy, I want you to copy that into your notes, okay? And you're going to submit that along with your assignment. So anytime you see something that says copy, I want you to write it down because there's a definition. So you'll be writing down this part here into your book. You don't have to do it right now, but when you get the assignment, because you're not going to have time, I'm going to go through another slide. So you'll be copying that, and then you're going to be adding it to the answers to the problems that I give you. So here's an example. If we have a fraction 4 over 5, it's a rational number. We put in our calculator 4 divided by 5, we get 0.8. Okay? If we have 2 divided by 3 and put in our calculator, we're going to get 0.6666 repeating. It'll probably only go to 5 or 6 or 7 on your calculator because that's as much as your screen will show. But it means it goes on forever. Those dots mean they go on forever, never stop. If I were to round that off, first of all, if I'm going to write it, we write it as 0.6 with the bar over the top. The bar over the number means it repeats. Okay? If I have a mixed fraction, I have a whole number, 7, and I have a fraction, 3/4. What I do is my 7 stays the same. It's a whole number. And if I take my 3 over 4 and put it in my calculator, I'm going to get 0.75. So I write 7.75. That's the same. That's equivalent. This is a fraction, mixed fraction, and this is a decimal fraction. Here, if I want to change that, it can be negative 4 over 5. I can write it as minus 4 over 5 or negative 4 over 5. And then if I put in the calculator, I'm going to get a negative 0.8. It's going to be 0.8, just like here, but now it's going to be negative because one of the numbers is negative. If one is negative, then the whole thing is negative. Minus 2 over minus 3. Remember, if there are two negatives, they'll cancel out. So that's the same as 2 over 3, which is going to be a positive 6.6666 going on. So we just write it as 0.6, put the bar over it. Okay? Excellent. So that's converting a fraction to a decimal. A negative divided by a positive is always negative. A negative divided by a negative is always positive. Those are the rules. Now, the last thing is placing decimals and fractions on a number line. Remember, a number line is a number that we make, and generally we'll divide it between positive numbers on the right side and negative numbers on the left side, and we got the 0 in the middle. You can divide the numerator by the denominator to get a decimal value if you have a fraction. So if we have to place negative 3.4, what I need to do first is write all the numbers down. So I start with my 0. I know that I have to go to at least minus, it's going to be bigger than minus 3, so I'm going to have to go up to a minus 4. It's going to be between minus 3 and minus 4. This number is between those two. So I write my number line 1, 2, 3, 4, 5. Here, minus 1, 2, minus 3, minus 4, minus 5. Minus 3.4 is in between minus 3 and minus 4. Well, that's almost half, eh? If we were to go directly half, it would be minus 3.5, 3.5. But 3.4 is a little bit smaller, so we go 3, and we stop just before we get to the 3.5, and there is our point for minus 3.4. So if you're not sure where to go, find out where 3.4 is, the positive. If you don't know where the negative goes, do the positive first. So 1, 2, 3, 4. Again, halfway between 3 and 4 is 3.5. So there is 3.4, positive 3.4 up there. And over here would be negative 3.4. Excellent. So there we are. Just quickly looking at this, I need to go between 1.75 and negative. So I have to put numbers here. Well, I know I have to be at least up to 2. So I'm going to have a 0. So if I have this as 2, and a 1, and a 0, a minus 1, minus 2, and a minus 3. So 3 rational number between 1.75. Well, where's 1.75? is going to be, if I go halfway in between here, that's 1.5. So 1.75 be there. So there's one number, 1.5. That's smaller. Then I could go to, it doesn't matter, I could write -1. That's in between. My smallest number is -2.5. So I come down to -2, -3. So halfway in between is going to be -2.5. So I could put this number, -1.5. So this number, and this number are all in between. They're in between here and here. Okay? This is the biggest, smallest number that we have, and this one is the biggest number. So these three numbers are in between. They're in between these two values. Okay? So we're going to leave it at that. That's just another example. Now, if you have to go least to greatest, it means that we have to find out where these numbers are first. Least means smallest to the biggest. Least is the smallest to the biggest. So we have to go with plotting these numbers. Where is 0.35? Well, we know that 0.35 is going to be in between 0 and 1, because halfway is going to be 0.5. So 0.35 could be somewhere around here. 2.5. Well, here's 2, there's 3, well, halfway in between be 2.5. Minus 0.6. Well, there's 0, there's -1, halfway is -0.5, so minus 0.6 is there. Okay. 1.7. There's 1, 2. Halfway in between is 1.5. So it's going to be somewhere around, my pen is not exact, but 1.7. There. It's in between 1 and 2. It's 1.7. Minus 3.2. Well, there's -3. Minus 4. It's got to be in between these two. So I'm going to say it's about there. Minus 3.2. And then minus 0.6 repeating. Well, it's going to be between 0 and here. We already have 0.6. And remember that this is going to be 6 over 10. And 0.666 is 6 over 9. It's going to be a little bit different. So we can put it over here between 0 and -1. Okay, so now we got them arranged. The smallest is minus 3.2. Next one is minus 3.6, 0.6, minus 0.6 repeating, 0.35, 1.7, and 2.5. And there we got them ranged from least to greatest. Excellent. Okay. There we have them right there. I put them on there for you. These ones here, they're acting ordered from minus 3/8, 5/9, 10s. We have to look at all the positives first. Maybe put those on first. The positive one, the positive one, the positive one. And we have to put them on the line. So one way of doing this, 5 over 9, we have to know what it is as a decimal. So change that into a decimal. Change all of these numbers into decimals. And then we can put them on the number line in here. All right. So minus 10 over 4, we have 10 over 4. It's going to be 2. If we divide that in our calculator, it's going to be 2 and 1/2. And it is a minus 10 over 4. So it's going to be minus 2.5. So I go here, minus 1, minus 2. There's minus 2.5, and there's minus 10 over 4. So if we change these things to decimals, we can put them on the line. 7 over 10. We put that in our calculator, and we get 0.7. So we look on here, there's 0, there's 1, and there is going to be 0.7 right there. So we put 7/10 there, and so on. Okay? So that example would be on your lesson plan as well. So you can copy this one when you get to your assignment. It's going to ask you to copy this into your paper. So it's copy. And you're going to make a number line, and you're going to put these numbers on the number line from these two grades. So I'm going to hand you out this task rubric. Today you're just going to do this handout. You're going to see handout 1, A and B. And you're going to give you copies of these textbook questions, 5, 6, 7, 8, 9, 10, right in here. So you're going to do this one and this one for today. I've got it spelled out in the next sheet. All the notes that we said copy, you're going to copy them down. Practice questions. And tomorrow I'll give you a formative question. You won't have it today. So this is going to be the handout I gave you. It gives you examples. And then you'll see part A, part B. This is what you're going to do for an assignment. And then I'm going to give you copies of the pages. And there'll be 5, 6, 7, 8, 9. If you're not doing them all, you just do the ones that I gave you. Okay? So if I go back to my task sheet, you see here I'm saying do number 5, 6, 7, 8, 9, 10, CD. So you're going to be doing on those pages 5, 6, 7, 8, 9, and 10, C, D, and I think there's a 12 one as well. (11) and 12C. So we go back. 11 and 12C. Okay? So you just follow the instructions on the task sheet that I'm going to hand to you or send to you, and then you'll complete those and file them in by 3 o'clock tomorrow. All right. Thank you. Shut this off.